My lab is at the House Research Institute in Los Angeles, and we work on cell cycle because cell division is one of the two components that is absolutely required for regeneration. The first is that you make new cells after you've lost them, and the second is that you turn those cells into the sensory cells that you need to hear with. And both components are really important, but they're separable in the sense that we can study aspects of them differently. And one important aspect of how you make more cells is the machinery that allows cells to divide, and that's why we study the cell cycle. And so a lot of our focus is on the supporting cells. We don't think that we will be able to replace the sensory hair cells by getting sensory hair cells to divide. We think that if we force sensory hair cells to divide, they'll actually probably die again. But we think that we may be able to trick the supporting cells into dividing, and then we're faced with the problem of, are they able to change into new cells, hair cells and supporting cells? Now we know that the cells that both of those cells came from embryologically were the same. So they came from what is known as a common progenitor, and so we're hopeful that the supporting cells will be able to replace both the lost hair cells and themselves and the supporting cells. And we know that that's what goes on in other animals. So in other animals, like birds, when you deafen a bird, for instance, in a matter of weeks, it undergoes complete recovery of its hearing. And that's because those supporting cells can respond to the loss of the sensory cell by either dividing and then turning into a cell, or actually turning into a sensory cell directly. And that's what ultimately we would like to achieve in us.